Dear students, in this video we are going to discuss US structures. So here we use very simple and easy method for drawing US structures. So drawing US structures we are using these 5 steps. In first step you have to calculate the total valence electrons. After that you have to find the central atom. In step number 3 you have to attach all atoms attached to the central atom with a single covalent bond. In step number 4, you will complete electrons on all atoms which are already attached with central atom. How many electrons you have to complete? 8 electrons for all atoms except hydrogen. And in step number 5, after completion of electrons, check your central atom. Also complete electrons around the central atom. Now we use these 5 steps in our examples. We take first example carbon tetrachloride CCl4. So our first step is calculate total valence electrons in carbon tetrachloride. So in carbon 4 electrons, chlorine 7 electrons, and how many chlorine atoms? 4. So multiply these 7 electrons by 4. Total electrons will be 32. So we have 32 valence electrons in CCl4. Now, what is step number 2? Find the central atom. Now, what is the central atom? That atom is considered as a central atom which is 1. So here, carbon 1 atom and chlorine 4 atoms. So carbon will be the central atom. Okay, in step number 3, attach all atoms by single covalent bond with the central atom. So we have to attach all chlorine atoms with the single covalent bond to the central atom. Okay, step number 4, complete the electrons on atoms attached to the central atom. So here we have to complete electrons in all chlorine atoms. How many electrons? 8 electrons. Okay students, now here you see all chlorine atoms are already attached with one single covalent bond. So in one single covalent bond, how many electrons? 2 electrons. So 2 electrons are already there. So how many more electrons we have to complete? 6 more electrons. Okay, so let's complete 1, 2, 3, 4, 5 and 6, then 7 and 8. In this chlorine 1, 2, 3, 4, 5 and 6, 7, 8. In this chlorine 1, 2, 3, 4, 5, 6, 7 and 8, and in this chlorine atom 1, 2, 3, 4, 5, 6, 7 and 8. Okay, now how many total electrons we have completed? 8 plus 8 plus 8 plus 8, total 32 electrons. It means we have completed all 32 electrons on all these atoms. Okay, now after this we have to move to step number 5. So what is step number 5? Complete the electrons around the central atom. Now check your central atom. How many electrons are there in central atom? Now 2 electrons here, 2 electrons here, 2 electrons here and 2 electrons here. So there are 8 electrons in carbon in the central atom. So it is already complete. So this is your correct Lewis structure. Okay friends, now here we have NF3, nitrogen trifluoride. Now here we use same 5 steps. What is step number 1? Calculate the total valence electrons. So how many valence electrons in nitrogen? 5. And fluorine 7. How many fluorine atoms? 3. So multiply by 3. Total 26 valence electrons. in nitrogen trifluoride. Okay, now step number 2, find the central atom. So what should be the central atom? Nitrogen, because it is 1. Now step number 3, attach all atoms by single covalent bond with the central atom. Okay, now there are 3 fluorine atoms attached with the central atom by using single covalent bond. Okay, now complete electrons. Step number 4, complete the electrons on atoms attached to the central atom. So 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6 and 7 and 8. And in this fluorine 1, 2, 3, 4, 5, 6, 7 and 8. So we have completed 8 electrons in all fluorine atoms. Okay, now how many total electrons we have put in this structure? 8 plus 8 plus 8, total 24. Now here we have 26 electrons. It means we have 2 extra electrons. Okay friends, if you have 2 extra electrons here, put those extra electrons on the central atom. So these extra electrons on central atom are known as lone pair. Okay, now you have completed 26 electrons on this structure. Now after that we have to move to step number 5. What is step number 5? Complete the electrons around the central atom. Now check your central atom. 2 electrons here, 2 electrons here, 2 electrons here, 2 electrons here. So total 8 electrons are present in the central atom. So its last shell is complete. So this is our correct Lewis structure. Now let's move to our next example, that is water. Now here we use same 5 steps. First, calculate the total valence electrons. Total valence electrons 8 in water. Second step, find the central atom. Oxygen will be the central atom. Now step number 3, attach all other atoms by single covalent bond with the central atom. Okay, so attach 2 hydrogen atoms by using single covalent bond with the central atom, oxygen. Okay, next, step number 4, complete the electrons on atoms attached to the central atom. Okay friends, in hydrogen, maximum 2 electrons can be accommodated. So it already contains 2 electrons because it is attached with single covalent bond. So in single covalent bond there are 2 electrons. So don't put 2 dots on hydrogen. This is wrong. Okay, so it already contains 2 electrons. Okay, so this hydrogen also contains 2 electrons. It means 2 electrons plus 2 electrons, total 4 electrons are already there in this structure. Okay, now we have 8 electrons here, but we have completed 4 electrons on these atoms. It means we have 4 extra electrons. If we have extra electrons here, put those extra electrons on the central atom, as we have done in our previous example. Okay, so 2 electrons will be here and 2 electrons will be here. Now you have completed 8 electrons on this structure. Okay, after that move to step number 5. We have to check central atom. How many electrons in the central atom? 2 plus 2 plus 2 plus 2, total 8 electrons. So this is our Lewis structure for water. Okay friends, now move to next. Here is CH2O, that is formaldehyde. Now here we again use same steps, calculate the total valence electrons. So how many valence electrons in CH2O? There are 12 valence electrons. Okay, find the central atom, carbon and oxygen. Now here is the problem. Now carbon is present and oxygen present. What should be the central atom? carbon or oxygen. Okay friends, if this situation happens, now you will take the least electronegative atom, that is carbon. Carbon is less electronegative than oxygen, so carbon will be the central atom. Okay, now attach all atoms by single covalent bond with the central atom. Okay friends, in step number 4, complete electrons on all atoms. Okay, for oxygen 1, 2, 3, 4, 5, 6, 7 and 8, and for hydrogen 2 electrons, these are already present, and for this hydrogen 2 electrons, these are already present. Okay, now we have completed our electrons. Now check how many electrons we have completed. 8 plus 2 plus 2. It means we have completed these 12 electrons on our structure. Okay, after this, we have to move to step number 5. Complete the electrons around the central atom. Now check central atom. How many electrons in the central atom? 2 plus 2 and plus 2. Total 6 electrons. It means this central atom, carbon atom, still needs 2 more electrons. Now we have already completed 12 electrons. We don't have extra electron. So what should we do? In this case, what happens? These 2 electrons from oxygen atom, these are changed to single covalent bond. So our correct structure will be this one. Okay friends, now move to next example. Okay friends, now we have another example, SO2. Now this example covers our all the discussion which we have already done in our previous examples. Here we shall use same 5 steps. Now step number 1, calculate the total valence electrons. So how many total valence electrons in SO2? 18, because sulfur present in group number 6, so there are 6 electrons, 6 valence electrons. Oxygen present in group number 6, 6 valence electrons, but there are 2 atoms of oxygen, so multiply 6 with 2, so total 18 electrons. Okay, step number 2, find the central atom. So what should be the central atom? Sulfur. Step number 3, attach all atoms by single covalent bond. Now step number 4, complete electrons on all atoms. So 1, 2, 3, 4, 5, 6, 7 and 8, 2 already there. Okay, so in this oxygen atom, 1, 2, 3, 4, 5, 6 and 7 and 8. So we have completed 8 electrons. 8 electrons here in this oxygen, 8 electrons here in this oxygen. So 8 plus 8 total 16 electrons we have drawn on this structure. But here we have 18 electrons. It means we have 2 extra electrons. So what should we do? Put those 2 extra electrons on this central atom, sulfur atom. Okay, now we have completed our 18 electrons here on this structure. Okay, after that, move to step number 5. Check your central atom. How many electrons in this central atom? Here 2 plus 2 plus 2. 6 electrons. It means this sulfur still needs 2 electrons. But we don't have extra electrons here. From where we will give these 2 electrons? Now what happens? One of oxygen atom shares 2 electrons as a single covalent bond. Now structure will be like this. Okay friends, so this is the structure of SO2. Now we shall discuss how to draw Lewis structure for an ion. We shall use the same 5 steps. Now first step, calculate the total valence electrons. Okay, nitrogen present in group number 5, so 5 valence electrons in nitrogen, and oxygen 6 electrons, and there are 3 oxygen atoms, so multiply with 3. Now here it is negative charge. So how many? Minus 1. So you have to add that one electron that is present here in this radical. So it is plus 1. So total valence electrons 24. Now second step, find the central atom. So nitrogen will be the central atom. Attach all atoms with a single covalent bond. Step number 4, complete electrons on all atoms. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6 and 7, 8. 1, 2, 3, 4, 5, 6 and 7, 8. Because two electrons are already present in single covalent bond. Okay, now we have completed 8 electrons in all oxygen atoms. Now 8 plus 8 plus 8 plus 8, total 24. It means we have completed our 24 electrons here in this structure. We don't have extra electron here. Now our step number 4 finished. Move to step number 5. Complete the electrons around the central atom. Now check central atom. How many electrons in the central atom? Now 2 plus 2 and plus 2. Total 6 electrons in nitrogen. It means this nitrogen atom still needs 2 more electrons. So, but we don't have extra electron here. What should we do? Now what happens? One oxygen atom shares 2 electrons to make single covalent bond with nitrogen. So actual structure will be like this. Okay friends, as it is ion, so you must put brackets and after that you have to write the charge. This is Lewis structure for NO3 minus nitrate ion. Okay friends, now another thing. Now this nitrogen can make this double bond with any of these 3 oxygen atoms. So like this, all these structures are correct, but there is a very small difference: position of double bond. Okay students, so those structures which are different due to position of double or triple bond are known as resonating structures, and this phenomenon is known as resonance. So what is actual resonance? Resonance basically the use of 2 or more Lewis structures to represent a particular molecule. In other words, the structures of same compound having different pairing schemes of electrons are called resonating structures, and the phenomenon is known as resonance. So all these 3 are resonating structures, and we say nitrate ion shows resonance. We have similar example, carbonate ion. So here we use same 5 steps. So structure will be like this. And we can also write this structure as these 3 resonating structures. So we can say CO3 2 minus carbonate ion shows resonance. Okay students, here is a question. Can we use the same 5 steps for diatomic molecules? Yes, why not? So let's use these 5 steps for nitrogen molecule N2. Okay, calculate the total valence electrons. Nitrogen present in group number 5, so 5 valence electrons. How many atoms? 2 atoms. So 5 multiplied by 2, total 10 valence electrons. Okay, find the central atom. Okay friends, as both atoms are same, So we can consider one atom as a central atom. Okay, so we represent it with blue ink so we can differentiate. Okay, attach other atom with the central atom by using single covalent bond. Okay, what is step number 4? Complete the electrons on atoms attached to the central atom. So complete electrons 1 2 3 4 5 6 7 and 8. So we have completed 8 electrons on this nitrogen atom. Okay, now here we have 10 electrons. It means we have 2 extra electrons. So put those extra electrons on the central atom as we have done before. Okay, now we have completed our 10 electrons on this structure. Okay, now move to step number 5. What is step number 5? Complete the electrons around the central atom. Okay friends, now when we see this central atom, how many electrons in central atom? 1, 2, 3 and 4. Central atom contains 4 electrons. It means this central atom still needs 4 electrons to complete its 8 electrons. So what should we do? Now we don't have extra electron here, so this nitrogen shares its 2 electrons to make single covalent bond, and again it shares these 2 electrons as a triple bond. Now how many electrons in nitrogen in central atom? 2 plus 2 plus 2 and plus 2, total 8 electrons. Now the correct structure, Lewis structure for nitrogen is N triple bond N. Okay friends, even we can use these 5 steps for any type of molecule, but there are some exceptions. Those exceptions are due to octet rule. We shall not discuss here. Dear students, now we shall talk about formal charge. Basically, formal charge is the difference between the valence electrons in an isolated atom and the number of electrons assigned to that atom in a Lewis structure. Now here we have a formula. Formal charge of an atom in a Lewis structure, that is equal to number of valence electrons in that atom when it is separate, minus total number of non-bonding electrons, or we can say total number of lone pair electrons, minus 1 by 2 total number of bonding electrons. Okay, here we have example, this formal charge. Okay, let's calculate formal charge for each atom. First calculate for sulfur. Formal charge on sulfur will be total number of valence electrons in sulfur 6 minus lone pair electrons. How many lone pair electrons here? 2 electrons, so minus 2 minus 1 by 2, this is in formula, into how many bonding electrons around this sulfur atom? 2 here, 2 here and 2 here, so total 6 electrons. Okay, so when we use simple calculation, 6 minus 2 minus 3, it means plus 1. So formal charge on sulfur is 1. Now for this oxygen, okay, oxygen present in group number 6. So how many valence electrons? 6. Minus how many lone pair electrons? 2 plus 2, 4. So minus 4. Minus 1 by 2, how many bonded electrons present? How many bonds present? 1 and 2. So 2 mean there are 4 electrons, bonded electrons. In one bond there are 2 electrons, so 4 bonded electrons. So when we use simple calculations, it is 0. Now we use this oxygen atom. Now oxygen, how many valence electrons? 6 minus how many lone pair electrons? 2 plus 2 plus 2, 6. So minus 6 minus 1 by 2, this is in formula, and how many bonded electrons? 2. So what is the answer? -1. So formal charge on this oxygen atom is -1. So in all these three atoms, this oxygen has 0 formal charge, this sulfur has +1, and this oxygen -1 formal charge. Okay friends, so now question is why we use this formal charge? What is the benefit of this formal charge? In In fact, formal charge tells us about the preferability of the structure over the other structures. So that structure with no formal charge is preferable than that which contains some formal charges. We shall discuss in our next examples. Now, Lewis structures with large formal charges are less plausible than those with small formal charges. Okay, students, but if we have same formal charges on all atoms, now what happens? Now, those Lewis structures having similar distribution of formal charges, the most plausible structure is the one in which negative formal charges are placed on the more electronegative atom. Okay, we shall discuss all these three properties in our next example here. Now we have two structures of formaldehyde, structure A and structure B. When we calculate formal charges for hydrogen, it is 0 in both structures. For carbon here, when we use formula, so it is -1, and for oxygen, when we use formula, it is +1. Now in structure B, for carbon, formal charge is 0 when we use formula, and for oxygen, it is also 0. Now which structure should be preferable? Now, this is our first characteristic. A Lewis structure in which there are no formal charges is preferable to one in which formal charges are present. So here no formal charges are present. So structure Lewis structure B is preferable. Example. Now from these three structures, which structure is preferable? SCN minus. Okay, so we have three structures. When we calculate formal charges, now here we have -1, 0, 0 in structure A. In structure B, same charges but distribution is different, 0, 0, -1, and in structure C, 1, 0 and -2. Okay, now here in structure C, what happens? It is not preferable. Why? Because it has higher formal charges on each atom than structure A and B. So this is not in our account now. Now we compare structure A and B. Okay. Now what should be preferable? Here structure A -1 on sulfur and structure B -1 on nitrogen. Okay students, we have discussed as third characteristic. Now that structure will be more plausible in which minus formal charge will be on that atom which is more electronegative. Now sulfur is more electronegative or nitrogen? Nitrogen is more electronegative than sulfur. So what happens? Structure B is preferred because the negative charge is on the more electronegative atom, nitrogen. So this is your preferred Lewis structure. Okay friends, hope you understood all these things. Okay friends, hope you understood all the discussion we have done in this video, but still if you have any question, just write that question in comments below. Also for more videos, please subscribe and press bell icon so you can get my latest videos.